Hi everybody, today we are going to start talking about how to find the determinant of a square matrix. Okay, so the first thing we're going to talk about is how to find the determinant of a 2 by 2 matrix, which is really easy to do because there's a nice formula that works. Now this should look familiar because it was in the formula to find the inverse of a 2 by 2 matrix. But essentially, you're simply taking these two terms and multiplying them, and then subtracting the product of these two terms. So you're multiplying across and subtracting those two products. Now the way that you notate a determinant, there's two ways. You could either write DET and then parentheses A, which is how you might see it in a graphing calculator, or you can use a symbol like this. I know it looks like absolute value, but when we're working with matrices, it means determinant. And notice here, since we're finding the determinant, we don't have brackets anymore, it's those straight lines. So make sure that you are using the appropriate notation when finding the determinant. Okay, let's give a few of these a try. So for matrix A, the determinant of A, remember we just multiply across, so 2 times 2, and then we subtract the product of 1 and negative 3. So that's essentially 4 plus 3, so it's just 7. And that's all there is to it. So the determinant of matrix B, 2 times 2 minus 4 times 1, which is 0. So if you remember from yesterday, if your determinant is 0, that means that your matrix does not have an inverse. But that's just a little bit of bonus knowledge for you. Okay. Let's find the determinant of matrix C. So we do 0 times 4 minus 2 times 3 over 2. So it's essentially just negative 3. Okay, go ahead and pause the video and give these three a try. All right, let's check. For matrix A, it should be negative 7. For matrix B, it should be positive 10. And the determinant of matrix C is 0. One interesting case I want to point out is the determinant of a 1 by 1 matrix, and it's just the value of the only element. So it's pretty straightforward. Okay, now, the next thing we're going to talk about is one of the small steps in finding the determinant of a 3 by 3. So one of the things that we'll need to find is what's called the cofactors. And to find the cofactors, you have to find what's called the minor. So this slide might look a little bit overwhelming, but it's just following the same process every single time. So first you have to start by finding what's called the minor. And each entry or each element in your matrix has a different minor. So if you are finding the minor of, let's say, element 2, 3, that's the element in row 2, column 3, what you do is you actually delete the row and column of that element. So I would take out row 2 and column 3. And what you have remaining is a 2 by 2 matrix. So then you find the determinant of that remaining matrix using the little formula we just talked about. So essentially, for the minor, you're eliminating a row and a column, allowing you to find the determinant of a 2 by 2 matrix. So that's what's called the minor. Now, the cofactor has a little formula right here, which looks a lot scarier than it is. To find the cofactor, you essentially take the minor, and then you either multiply it by negative 1 or positive 1. So how you decide is you just add up I and j. You add up the number row and the number column. So the rule of thumb is if the sum in I and j is even, well, if you raise negative 1 to an even power, it cancels out the negative. So you're essentially multiplying by positive 1. So the number doesn't change, meaning your minor and your cofactor are the same. If the sum of I and j is odd, well then here in this formula, you're raising negative 1 to an odd power, which maintains the negative. So you essentially take your minor and you multiply it by negative 1. So the number becomes the opposite. So this sign pattern is essentially what's being created by this that's highlighted in blue. It creates kind of this checkerboard of positive and negative. Now, I do want to point out that this is not the signs of your results. It's the sign of what you multiply by. So here you multiply by positive 1, negative 1, positive 1. Here you multiply by negative, then by positive, then by negative, then by positive. So all you really have to know is that if I plus j is even, your number doesn't change. If I plus j is odd, your minor becomes the opposite for the cofactor. And this is definitely something that's much easier to show than to tell. So that being said, let's give this problem a try. So go ahead and write down matrix A because I'm going to be scrolling down quite a bit just so I have enough room. So we're going to start by finding the minor of 1, 1. So the element of row 1, column 1. So we're going to take the determinant of what's left over when I cancel out row 1 and column 1. So I'm going to take the determinant of this. And notice that now, since we're taking the determinant, I have straight lines instead of brackets. Okay, well, we know how to find the determinant of this. We multiply across and take the difference. So it's just going to be negative 1. All right, let's find the minor of row 1, column 2. So imagine I take out row 1 and column 2. You can see that what we have left is 3, 2, 4, 1. And then we take the determinant of that, so it's going to be 3 minus 8, which is negative 5. So we're going to follow that same process, going all the way across. So let's find the minor of 1, 3. So imagine we take out row 1 and column 3. What we have left is 3, negative 1, 4, 0. So we have 0 minus negative 4, so it becomes positive 4. Now let's go down to the second row, row 2, column 1. So we're finding the determinant of 2, 1, 0, 1. If I take out row 2 and column 1, and that will give us a determinant of positive 2. Let's find the minor of row 2, column 2. So we're going to take the determinant of 0, 1, 4, 1, and that will be negative 4. And then let's find the minor of row 2, column 3. So we'll take the minor of 0, 2, 4, 0, and we get negative 8. All right, last row. The minor of row 3, column 1 will be the determinant of 2, 1, negative 1, 2. So we have 2 minus negative 1, which is positive 5. The minor of row 3, column 2 will be the determinant of 0, 1, 3, 2. So it will be negative 3. And last but not least, the minor of row 3, column 3 will be the determinant of 0, 2, 3, negative 1. And that will become negative 6. Okay, so now we need to go back and find the cofactor of each of those terms. So that's easy to do. So remember, we're really just looking at the sum of I and j. And remember, if this sum is even, the number stays the same. If the sum is odd, it becomes opposite. So let's start by finding the cofactor of element 1, 1. So I start with my minor. Since the sum is even, I'm multiplying by positive 1. It stays the same. For this problem, or for 1, 2, my minor is negative 5. Since the sum of 1 and 2 is odd, the sign is going to change, so it becomes positive 5. All right, when we do 1, 3, my minor is 4. The sum is even, so it stays the same. Now let's do 2, 1. Here's my minor. I'm going to multiply by negative 1, since 2 plus 1 is 3, and we get negative 2. Here, it's going to stay the same because the sum is even. Of course, you don't need to show out this step. It's just kind of for the notes to give you the benefit of knowing where we get our answers. And here we have an odd sum, so the sign will change. And moving on to our last row, the cofactor of element 3, 1. The sum is even, so it will stay the same. For 3, 2, the sum is odd, so the sign will change. And for element 3, 3, the sum of 3 and 3 is even, so our number stays the same. So this is the process of finding the minors and the cofactors. So remember, we're going to be using cofactors in the next video when we're finding the matrices of a 3 by 3 or larger, or the determinant of a 3 by 3 or larger matrix. But for today, we're just going through the process of finding those minors and cofactors. So go ahead and pause the video and see if you can repeat that process and find all of the minors and cofactors of matrix A. All right, so I would start just by checking your cofactors, because if all of your cofactors are correct, then that means that your minors were correct. If your sign is off, it might have been an issue with understanding when to change the sign and when not to. But if the absolute value of your term is off, then there was probably some issue with creating the new matrix to find the minor. So make sure you can check your work. And make sure you really understand this, because in the next video, we're going to be finding the determinants of larger square matrices. All right, that's all for today. Thank you for watching.